some transformations to them. So this word transforming in math just refers to moving a graph around the coordinate grid. So we're going to add and subtract different values to y equals x squared, sort of our base graph, and see what happens to the graph. We're going to skip this getting started, and we're going to go straight to the constructor understanding. So it says, using graph technology, start with the equation of the quadratic function y equals x squared plus 2, and put different numbers where the q is and see what happens to the graph. So let's go to our graphing technology here. Before we get started, though, I just want to remind everybody about sort of the base function y equals x squared, because that's kind of where everything starts today. This graph looks like this. So I'm just going to 1, 2, 3, 4. 1, 2, 3, 4. You should graph this as well, and you should be comfortable graphing this from memory. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll go to 10. Okay, so this graph looks like this. So it has the vertex right at the origin at 0, 0, and then it goes 1 up, 1 over, because 1 squared is 1, and then 2 squared is 4. So it'll be 2, 4, and 3 squared is 9. It'll look like this. It'll have this parabolic shape, and then it'll be symmetric on the side. So negative 2 squared is 4, negative 3 squared is 9, and I'll have this parabolic shape. It's a curve, not a V at the bottom, and it's symmetric. So just to remind you guys, this point here, the minimum point is called the vertex, and there's an axis of symmetry at is the axis of symmetry at x equals 0. So we're going to see how adding and subtracting different values to this graph or multiplying different numbers is going to change what it looks like. You're going to see it stretch and move around the grid. Okay, so first we're going to explore what happens if we just simply add a number. So let's go to our Desmos screen. The awesome thing about Desmos is we used to have to do all this by hand, but now we can do it easily with technology. So you'll see if you put plus Q, it'll ask you add slider Q. We're going to do that. And then what you can do here is just move this around and see what happens when you change the value of Q. So when Q is negative, you'll see this graph has shifted downwards. And then when Q is positive, you'll see the graph shifts upwards. Nothing else happens to the graph. It simply moves up or down depending on that value of Q. So let's sort of summarize that down here. So when you have different values of Q, it's going to shift the graph up or down depending on what those values are. So if Q is positive, we're going to have a graph that looks like this, right? Shifted up. When Q is equal to 0, when you don't add anything on, it just looks like this. The origin's at, the vertex is at the origin. And then when you have a negative value of Q, you're going to have the same graph, but it's just going to be shifted down. Shift down. Okay, let's see what happens if you, instead of adding or subtracting a value on the end, what if you add or subtract a value from the x? So within a bracket like that. So let's see what goes on if you put a different value in there. So instead of adding and subtracting outside of the square, instead we're going to put a bracket around the x. Oops. Add or subtract, oops, let's put the x squared on the outside. Okay, let's add a slider P like this. And let's see what happens. So this time, oh, look, instead of shifting up or down, you're shifting left and right. So when you add, when you put a positive number in there, you actually shift the opposite way. So you're shifting to the left. And then when you put a negative number in there, you're shifting to the right. Okay, so let's describe that here. Where are we going to put that? Maybe just underneath. So let's put, when we have y equals, let's say x plus 2 squared, you're going to be over here, 2 to the left. And then when you have, let's say, x plus 3 squared, I don't know, or x minus 3 squared, when you put a negative number in there, you're going to be shifting it to the right. Okay, so let's just quickly summarize for adding and subtracting. When we add or subtract a number outside of the square, we're going to move the graph up or down. And then when we add or subtract a number inside the square with a bracket, we're going to move left and right. And actually, when you move left and right, the sign turns out to be kind of in the opposite direction. So if you put a negative number in there, like x minus 3, you're going to move 3 to the right in the positive direction. And then if you put x plus 2, for example, you would move 2 to the left. Okay, now let's play around with multiplying a little bit. We're going to go down to this part C here. And what happens if you multiply a number to the graph like that? So let's change it back again to x squared and put an a in front. Okay, so let's say a is 1. This is a normal graph, y equals x squared. So let's see what happens first if I increase a to be more than 1. We'll see the graph actually gets stretched vertically. It's almost like you took the tops and you pulled them upwards. And then if a is between 0 and 1, you'll actually see it gets like compressed, like squished down, and it's like it's a shallower parabola. Now let's see what happens here when when a goes negative. Oh, do you see that? It flips. So once a becomes negative, if you have a negative number in front of the x squared, it's now a downward facing parabola. And if you have a number greater than or like more negative than -1, it gets pulled and stretched again. So the negative sign just indicates whether it's going to be facing up or down. And then the actual value of a tells you whether it's going to be stretched or more compressed if it's less than 1. Okay, so let's draw a couple of different scenarios here. So let's say a equals, or we'll say a is greater than 1. It's going to be stretched. So it'll look like this. It'll be like skinnier. So it's stretched vertically. If a is between 0 and 1, example like 0.5, it's going to be compressed. Vertically. So maybe something like this. Notice the vertex doesn't change in any of these scenarios. It's just stretching it or compressing it. And then if a is less than 1, less than 0, negative, you're going to have a downward facing parabola. And the stretching and compressing will just depend on the value of a. Okay, so now that we've kind of looked at those 3 different scenarios where you're adding or subtracting values and then multiplying by a number, you're going to put it all together and kind of summarize here. And so you can have Desmos open and then go through these on your own. Stop it here.